Welcome to the last part of the lesson on optimization. In this part, you're going to see examples of speed, distance, and time problems. So let's start by looking at a problem that has to do with time as well as speed. So Anna's house is 9 kilometers west of Bob's house. At 8 a.m., Anna starts jogging south at 8 kilometers per hour. At 8:30 a.m., Bob starts jogging west at 10 kilometers per hour. At what time is the distance between Anna and Bob the smallest? And so we're told here that this is after Bob has started jogging. So let's take a look at the solution to this problem. So at 8:30, the situation that we have here is that Bob has traveled a certain distance. Okay, so we're told that, so Anna starts jogging south at 8 kilometers per hour. At 8:30, Bob starts jogging west. And so that means that Anna has a head start. Okay, so if we draw the diagram for this situation, initially Bob is 9 kilometers away. After 30 minutes, Anna has traveled 4 kilometers because Anna is able to jog at 8 kilometers per hour. So in 30 minutes, she has jogged 4. So she's covered 4 kilometers. She's traveled south. While Bob is still 9 kilometers away from Anna's house. And so the expression that can model Anna's distance, the distance that she has traveled from her house, is 4 plus 8t. So 4 is her initial distance from her house, and then plus 8, so 8 is her speed. So the speed times the time gives us distance. So 4 plus 8t is the expression for Anna's distance. Now for Bob initially is 9 meters away from this point here, Anna's house. And then what starts to happen is, so Bob is traveling at 10 kilometers per hour. So Bob is going to get closer and closer to Anna's house. And so this expression here, 9 minus 10t, so 9 is the original distance that Bob is away from Anna's house, minus 10t. So 10 is his speed, and then t is the time. And so what we end up getting here is we end up getting a triangle, a right triangle. So this side of the triangle is 9 minus 10t, while this side of the triangle is 4 plus 8t. And the distance that we're looking for, or we're trying to find, is the shortest distance between Bob and Anna. And so using Pythagorean theorem, we get this equation. So d is equal to the square root of 4 plus 8t squared plus 9 minus 10t squared. And then what we can do to make it easier to then take the derivative is we can expand. So we can expand the 4 plus 8t squared and the 9 minus 10t squared. So expanding this out and then collecting like terms, we end up getting 97 minus 116t plus 164t squared under the square root. And so from this point on, we're ready to take the derivative. So taking the derivative of the distance function. So first, I use the power rule here, as well as the chain rule. Simplifying this further, I end up with negative 58 plus 164t over the square root of 97 minus 116t plus 164t squared. I then proceed to set the derivative equal to 0. So in this case, I just have to set the numerator equal to 0 because the denominator ends up getting multiplied by 0 and goes away. So setting the numerator equal to 0 and then solving for t gives me 0.35 hours. Now, to make sure that this truly is a minimum, I use a number line here. So my critical value is 0.35. Now I have boundaries here. So the distance between Anna and Bob cannot be less than 0. And also, when looking at the variable here, t, the time cannot be greater than 0.9. And the reason for that is if we look at this expression here, the 9 minus 10t, it will take Bob 0.9 hours to reach Anna's house, and then at that point he's just gonna go past Anna's house while Anna just is gonna continue to travel this way, right? So for that reason, his distance is gonna start to get farther and farther away from Bob's distance is gonna start to get farther and farther away from Anna, and for that reason, there's no point of going beyond the 0.9 hours. So 0 and 0.9 are the endpoints of the interval here, and 0.35 is a critical value. And so using a number line and creating a sign chart and looking at the sign of the derivative, first it's negative in this interval from 0 to 0.35, and then from 0.35 to 0.9, it ends up being positive. And so the function is first, the original function, distance function is first decreasing, and then it starts to increase, which tells us that we have a minimum. And so this chart just confirms that we have a minimum. Now the last thing to do is to actually find the time, at what time the distance between Anna and Bob is the smallest. And so this is all from 8:30. So to find the time, we would have to add 0.35 times 60. So we have to convert the 0.35 hours to minutes, and then add the minutes to 8:30. And so we end up getting so 0.35 times 60 is approximately it's 21 minutes. And so at 8:51 a.m. Anna and Bob are the closest to each other. So Anna and Bob are closest at 8:51 a.m. All right, now let's take a look at another word problem that involves distance, speed, and time. You are a competitor in Survivor. Your challenge this week is to beat the other team in a rowing or running race. Your boat is located at the furthest end of one of the riverbanks. From there, you must row across the 200-meter wide river and then run to the finish line located at the end of the opposite shore. The shore is 500 meters in length. You know that you can row at 1 meter per second and you can run at 2 meters per second. You may choose to row across the river at whatever angle you would prefer. What is the minimum time that it will take you to reach the finish line? So let's first look at a diagram of this situation. Now, there are actually 3 different cases here, but so you're located at this point over here initially, 200 meters away from the shore. Now, along the shore, if you just swam from this point where you start to the shore, you would then have to run along the shore, and you would have to cover a distance of 500 meters. So the first case here that we have to consider is a case where you would just swim straight across the river and then you would run along the shore. Now, to find the time that would take, we would have to take the distance that you would have to swim in the water for, right? So take the distance in the water, so the 200 meters, and divide it by the speed that you can swim at in the water. So 200 divided by 1, that's for this time here. Now along the shore you can run at 2 meters per second. So to find the time that it would take you to run along the shore, you need to take 500 and divide it by 2. Now adding these two values gives us 450 seconds. Okay, so it would take that long if you were to take that route. Now the second case is to just swim right from this point, to swim all the way to the finish line and to not run along the shore at all. Now the distance of this right triangle here, so the distance that you would have to swim, would be 538.52 meters. So you would just use the Pythagorean theorem to determine the length of the hypotenuse. Now the time for this would be, so the distance covered, which is the 538.52, divided by the time, divided by, the velocity or the speed in the water, which is just 1 meter per second. And so dividing 538.52 by 1 is just 538.52 seconds. So longer. It would take longer to just swim in the water. Now the third case and final case is to swim in the water part way and then run along the shore for the remainder of the distance to get to the finish line. And so in this case, we end up getting this right triangle here. One length of it is 200. This length I've denoted with x. Now the hypotenuse of this triangle is the square root of 200 squared plus x squared. And so that is just using the Pythagorean theorem, right? So if you take this side and square it, and you take x and you square it, you add them and take the square root. Now this distance here, the distance that you would have to run along the shore, is 500 minus x, because the total length of the shore here is 500. Now the expression that the equation that we get for the time, so the time function is, so the distance covered swimming in the water divided by the speed in the water, which is the speed at which you're able to swim, which is 1 meter per second, or the speed at which you can row in this case. So you're rowing at 1 meter per second, and then along the shore, the distance that you would have to travel is 500 minus x divided by the speed at which you can run, which is 2 meters per second. And so continuing with this, once we have our time function, the next step is to take the derivative, because we are trying to find the time that will lead to, basically what we're trying to do is we're trying to minimize the time. Okay, so we're looking for an x value that will minimize the time. So taking the derivative here, we end up getting 1/2 times 200 squared plus x squared to the power of negative 1/2 times 2x, so I use the chain rule here, minus 1/2. So I got 1/2 here. What I did is I took 500 and divided it by 2. That gave me 250. I took negative x and divided it by 2. So that's negative 1/2 x. Taking the derivative, we just end up with negative 1/2 here. The next step is to move the negative 1/2 over. So once we get the derivative, we set it equal to 0 to find critical values. So I moved the 1/2 over, I then cross multiplied, And then to get rid of the radical, the square root, I squared both sides. So I ended up with 200 squared plus x squared is equal to 4x squared. I then moved the x squared over to the other side. I got 200 squared is equal to 3x squared. And then solving for x, I ended up getting 115. Now taking this value for x and substituting it in to the time function here, I ended up getting 423.21 seconds. Now, to make this kind of more a time that's easier to understand, I took the time in seconds and I multiplied it by 1 over 60. So basically I divided by 60 to convert it into minutes. And that gave me 7.1 minutes. Now we can see that this time is less than the times that we got before, right? So we had 450 seconds for case 1, 538.52 seconds for case 2. And so for case 3, we got 423.21 seconds, which is less than the other two cases. So those other two cases are treated as our basically the boundaries of our interval. And so we can conclude that the minimum time it will take to reach the finish line is 7.1 minutes. And that brings us to the end of the lesson on optimization. Thank you for watching, and until next time.